math lovers. Welcome to notes number 5 of lesson of the prerequisite chapter number 3. We're going to talk today about polynomials. The first thing we're going to cover are the degrees of a polynomial. So think of a degree as your descriptor, an adjective. If I tell you about my car, it doesn't tell you too much, but if I tell you about my gray car with fancy wheels, it's a descriptor. It tells you more about it. Degrees also become really important to us when we talk about our graph. So we're look at the degree of the polynomial. I think you've done this before, so we'll go through it. The degree here, look at you take the sum of each term, the sum of the exponents on each term. So the exponent on here on this x squared is 2 and this y is 1, so the sum of that would be 3. So the degree there is 3. This is a third degree polynomial. If I have a binomial, here on I'm going to take the sum of these. The degree of the first term would be 3. The degree of the second term would be 5. And since 5 is higher than 3, the degree of the polynomial is 5. And then I'm looking at plain old 7. Well, that has no variables, right? No variables. I could also think about this as 7x to the 0 power. So my degree here would be 0. Okay. We also need to think about our standard form as we work through these. I know you've seen standard form all the way from pre-algebra days where you're writing the highest exponents to the lowest. Quick review of sum, difference, and multiplication of polynomials. If we have the sum, we're going to go ahead and we're going to add these two together. The parentheses don't really do anything for me here because I have my commutative property. I can go ahead and add in any order I want. So I've got, let's see, 3x squared plus 2x. Notice I don't have like terms until I get to this 3 at the end. So minus 5 and plus 3, which is, of course, minus 2. Okay. Difference, I have to think about the difference of these two. So I'm going to take this minus sign and I'm going to distribute it. So it'll be 3x squared minus 5 minus 2x minus 3. All right. Kids always lose that. Do not fall for that trick. So here our like terms are just, again, the constants. So it's 3x squared minus 2x. And then I've got the minus 5 and the minus 3, which is, of course, negative 8. All right, so minus 8. Multiplication, feel free to FOIL if you guys like to do the first terms, the first two terms together. So that would be 6x to the third. The outside terms, so that would be 9x squared. The inside two terms, so that would be negative 10x. And then the last two terms, so that would be negative 15. I never learned to FOIL. I instead used the Punnett square, which, remember, I showed you our very first day together. So feel free, either method, whichever you'd prefer to use, you can do that. And the last thing I want to talk about are the special products. There's a nice chart in your textbook on page 30. I think all of these are review for you. What I do want to draw your attention to are all the things you already know. So if I have a minus b times a plus b, that's the difference of two squares. And so right away, if you FOILed the whole thing out, you should be able to look at that and know that that's a squared minus b squared. That's a difference of two squares. If I have a plus b squared, remember that's the same thing as a plus b times a plus b. You might not need to write that out. You can go ahead and FOIL it, and you should know that that's a squared plus 2ab plus b squared. And I know in your Algebra 1 class, you FOILed and FOILed and FOILed and FOILed, so you could come up with this pretty quickly when you got down to it. Similarly, we could do that with the subtraction of our polynomial squared. So that would be a squared minus 2ab plus b squared. Again, that last sign is always going to be positive. Then we've got the ones we just learned. A minus b times the quantity a squared plus ab plus b squared. Does this look familiar? I hope it does, because we spent time on the very first day together talking about these cubes. All right, so if I go ahead, let's see, I make sure I copied it right. A squared plus, yep, my signs, notice I had same sign. So this is going to be a plus b a cubed plus b cubed, right? Throw parentheses around there to keep it neat, or not. Oh, wait, it's just going to be a minus. Hold on, hold the phone. Hold the phone. Let me make that a pretty problem here for you. Okay, product placement, the Bic whiteout eraser, beautiful product. That would be a cubed minus b cubed, okay? And this would be a cubed plus b cubed. Sorry about that, I got them mixed up there. And finally, my last one, which we don't use that much, but you know, it's in the chart. Ron, Our author really likes it. If we were to take these and we were to FOIL them out, okay, this would be a plus b times a plus b times a plus b. And similarly, we could do this down here for the minus. Now, you guys, Pascal's triangle would be fabulous right here, right? Those of you guys that know Pascal's triangle, you can look to row 3, you look at your coefficients. Your coefficients of Pascal's triangle are 1, 3, 3, 1, and that would give us the very special product of a cubed plus 3a squared b plus 3ab squared plus b cubed, all right? And so we would do the same thing here with the minus sign. Notice our signs are going to alternate every other sign. We will cover Pascal's triangle in the last chapter of the book. So probably in about May, we will cover that. Until then, you could look it up yourself, or you could go ahead and you can FOIL this out and then take your answer and FOIL it yet again so that you could have a cubed plus ab squared, or excuse, a squared b plus 3ab. I'm just double checking all my signs. You notice how it's power of 3, power of 2, power of 1, power of 0 on the a. And the same thing here. If I go the other direction, it's 3, 2, 1, power of 0. Okay? So have fun with your polynomials.